All right, this is section 6.2, growth and decay. We're going to start this section talking about solving differential equations. If I have y prime equals 2x divided by y and I want the general solution, it means I want to find the derivative. So y prime can also be written as dy dx, and I like that manner better for this process. We want to get all the x's on one side, all the y's on one side, so I want to multiply my y over. So I have y times dy dx equals 2x. Now in order to undo the derivative, I need a dx next to my x's. So I essentially just multiply that dx over to the other side. It's not technically multiplying there, but it's basically the same idea. And for our purposes, it works out. Now to get rid of those d's, the derivative symbols, we underderive, we antiderive. So the antiderivative of y is y squared divided by 2. Antiderivative of 2x is just x squared. And then we need a plus c. We only need one plus c anywhere because if I put a c on both sides, it's just a different constant and we would still call it c. Now I could also multiply everything by 2 to have y squared equals 2x squared plus some other c. I could get my x's and y's on the same side. It all depends what we're looking for. But we're going to focus on growth and decay. So if y is a differentiable function of t such that y is greater than 0 and dy dt equals ky for some constant k, basically it's saying the rate of change is proportional to y. Hey. Then the antiderivative would be y equals c e to the kt power. We'll get into that more later. But c is the initial value of y, k is our proportionality constant. Exponential growth occurs when your k value is positive, when k is bigger than 0. Exponential decay occurs when your k value is negative. There we go. So the rate of change of y is proportional to y. That just means, right there, that's how it's going to phrase it. That means dy dt equals ky, which means y is going to equal c e to the kt power. So when t is 0, y is 2. When t is 2, y is 4. What is y when t is 3? These are some initial conditions. When t is 0, y is 2. So I plug those in. 2 equals c e to the k times 0. Well, k times 0 is 0. E to the 0 power is 1, which means c is 2. Then I'm going to take my other condition, 2 and 4. 4 equals, we know c is 2, e to the k times 2 power. Now I can solve for k. I divide everything by 2. E to the 2k power, there we go. To get a variable out of the exponent, we take the natural log of both sides, and then we'll divide by 2. So k is natural log of 2 divided by 2. Now I can use all of that to figure out the value of y when t is 3. So y equals 2e to the ln of 2 divided by 2 times t. T is 3. And now I have a calculator problem. 2 times e to the natural log of 2 divided by 2 times 3. 5.657. Now we don't have any context there, just a value, but that's our answer. Now let's have some context. 10 grams of the plutonium isotope 239Pu were released in a nuclear accident. How long will it take the 10 grams to decay to 1 gram? Note the half-life is 24,100 years. So half-life means that the rate of change is always proportional to the amount of it that there is, which means we know y will equal c e to the kt power. We know that the half-life is 24,000 years. So that means in 24,100 years, so when t is 24,100, our y value will be half as much, which is 5. We also know that when t is 0, our y value was that initial 10. Use t is 0, y is 10 to find c. Oh look, c is 10. Remember that c is always that initial y value. And then we'll use y is 5, t is 24,100. to get our k value. 10e to the k times 24,100. We'll divide by 10. We get 1/2 equals e to the 24,100 k power. Natural log of 1/2 equals 24,100 k. And then divide by 24,100. Now this is a calculator problem if I ever saw one. We get negative 2.876 blah 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 e to the negative 5th power. So that actually means that k is negative 0.1234, then the numbers that were in my calculator. 1, 2, 3, 4, 5 movements gets us to the number my calculator said. That's what that e negative 5 means. And then we want to find how long it'll take to decay to 1 gram. So we know y equals 10e to the negative 2876t. There we go. I want to know how long it takes for y to be 1. Well, I would divide by 10. 0.1 equals e to this nasty looking power. I will take the natural log of both sides. And then I'll divide by this fun number. So I have kept that number in my calculator. I did all this work by hand so that I can take ln of 0.1 divided by second answer. That's going to give me a more accurate answer than using this rounded one I wrote down. So this says t equals 80,058.467 years. It's going to take 80,000 years. Whew. I don't plan to be around then. All right, another problem. An experimental population of fruit flies increases according to the law of exponential growth. There are 100 flies after the second day of the experiment and 300 after the 4th day. Approximately how many flies were in the original population? So we're trying to find C. And this one's a little different. So we know y equals c e to the kt power. 100 flies after the second day. So that means 100 equals c e to the 2k power. 300 after the 4th day, so that's 300 equals c e to the 4k power. Now I have to try to solve some stuff. I know that 2k times 2 makes 4k. Which means I could square this and square this. Some other c e to the 4k power. Hey, now I've got two things that equal c e to the 4k power. But whoops, I actually squared this whole thing. So this is technically c squared because the original c's were the same. So I did square that. But I can solve for e to the 4k power. Divide by c squared, divide by c. So 10,000 divided by c squared equals e to the 4k power. And 300 divided by c equals e to the 4k power. So I could set those equal to each other. And cross multiply. I could say c is 0, but it's definitely not. So I'm going to divide out of c. And divide by 300. I have 100 divided by 3 is c. So that's 33.3 repeating. And C is always the original population. That's that initial value. There were 33.3 flies, which doesn't technically work, but we always round to the nearest fly. So, all right, 4 months after it stops advertising, a manufacturing company notices that its sales have dropped from 100,000 units per month to 80,000 units per month. The sales follow an exponential pattern of decline. What will the sales be after 2 months? So our initial value is this 100,000. So that's our C. So y equals 100,000 e to the kt power. After 4 months, we're down to 80,000. So 80,000 is my y. E to the k times 4 months. I can solve for k now. Divide by 100,000. I get 0.8 equals e to the 4k power. Take the natural log and divide by 4. We find that k is natural log of 0.8 divided by 4, negative 0.0558 when I round. Now, I want to know the sales after another 2 months. So I want to know the sales when t is actually 6 months. Oops. So I'm going to take y equals 100,000 e to the negative 0.0558 times 6. Well, 6 months. So now I'll take 100,000 times e. I'm going to use second answer times 6. And I get 71,554.175. It's in units, so we probably would drop the decimal and say 71,554 units. All right, y is the temperature of an object in a room whose temperature is kept at a constant 60 degrees. The object cools from 100 to 90 in 10 minutes. How much longer will it take for the temperature of the object to decrease to 80? A note, Newton's law of cooling, the rate of change of temperature of an object is proportional to the difference between the object's temperature and the temperature of the surrounding medium. So this one has an extra little piece to it. So the rate of change of the temperature, that's our dy dt, is equal to, or it's proportional to, so k times the difference between the object's temperature, which is y, there we go, and the surrounding medium. We'll call that y 0 because it's a constant. We know that it's kept at a constant 60 degrees Fahrenheit, so we know y 0 is 60. So we know the rate of change is proportional to y minus 60. And now before we had dy dt is equal to ky. This is very similar, we just have a y minus 60 instead. That was y equals c e to the kt power. The difference here is where that 60 goes. So essentially what we do is solve this like a differential equation. We're going to divide by y minus 60, multiply that dt over. I get 1 over y minus 60 dy equals k dt, antiderivative. 1 over something is always natural log of the absolute value of that, equals kt plus c. And then we raise it up to an exponent. So y minus 60 equals e to the kt plus c. Well, I can separate this out into separate exponents. E to the kt times e to the c, which is just a different constant. C, e to the kt, but I still have the 60 to deal with. That 60 is just added on the end. Now we can get some of our work going. The object cools from 100 to 90, which means our initial temperature is 100. So y equals 100 e to the kt plus 60. We know it cools to 90 in 10 minutes. So 90 is the new temperature. 10 minutes is the time. Now we can solve for k. I'm going to subtract my 60. I'm going to divide by 100. I'm going to take the natural log of both sides. So natural log of 0.3 equals 10k, and then divide by 10. I get that k is about negative 0.120, really, but all right. That's not what it asked. How much longer will it take to decrease to 80 degrees? So I want to know what the time is when y is 80. So let's plug in everything I know. There we go. Subtract the 60. Divide by 100. Natural log. And divide by negative 0.12. So natural log of 0.2 divided by second. Answer, t is 13.368. But that's not the answer. It says how much longer. It's already been 10 minutes, so it's only going to take 3.368 minutes more. And there we have it. All right, your assignment on this section was only 2 questions.